Welcome at Hager & Werken in Duisburg, Germany, the specialist for specialties of dentists and dental technicians. We are pleased to be able to demonstrate the crown build-up with the refractory aesthetic ceramic system caratecoline, the economic ceramic material. Above all, the time-saving and easy handling, as well as the attractive price structure of this ceramic material, account for its economic efficiency. Likewise, advantages is the combination with the opaque system caratecoline. Hager & Werken offer a complete range of working materials for crown build-ups. The caratecoline basic assortment consists of dentin compounds in 16 vita shades to build up the dentine body, 5 enamel compounds to build up the cutting edges of the crown, the glaze powder GL, and the specific modeling liquid Carat UNF. In addition, Hager & Werken offer a number of accessory materials that are available in any well-equipped dental laboratory. At first, the dental technician prepares and fine blasts the metal framework as usual. 2 opaque layers made with caratecoline create the base for an optimal adhesive bond between the metal crown and the aesthetic build-up material caratecoline. Caratecoline base paste is evenly brushed over all sides of the metal cap. We recommend using the opaque flat brush to accomplish that task. In order to prevent any mix-up, an individual collect vessel is allocated for each type of utilized scatter crystals. The collect vessel is prepared prior to sprinkling the crown with biopaque scatter crystals, here light, to save material. The predefined graining facilitates an even layer thickness during the scattering process. Excess material is knocked off. Crown margin and crown lumen are worked over with a wet brush. The prepared crown is now placed on the furnace load carrier for the first opaque firing. The Orbatec ceramic furnace used here is set according to the firing chart. Start. The carrier platform gradually approaches the furnace chamber. Following a brief drying phase and once the firing temperature is reached, the load is completely surrounded by the furnace chamber and the vacuum firing is started. After this, the cool down also takes place step by step. Here the crown after the first firing. After cooling down, the crown is prepared for the second opaque firing with a color paste. For this, the dental technician uses a fresh flat brush. Any mix-ups must be entirely ruled out. He uses blue now to apply the caratecoline shade paste. The paste is rubbed and pushed in with a brush. Tapping causes the paste to settle properly. A new collect vessel is now used for the scatter crystals. In order to prevent any mix-ups, our technician already pre-allocated the appropriate scatter crystals. The crown is now sprinkled with caratecoline scatter crystals. Again, the excess is knocked off. The non-covered areas are now worked over as well. Due to their reflective performance, the scatter crystals create warm and deeply glowing colors. Due to the specifically coordinated consistency of caratecoline pastes and scatter crystals, an even layer thickness of 0.15 to 0.2 μ is attained. Once the ceramic furnace is set, the crown is placed on the carrier platform and loaded for firing. For the exemplified crown build-up shown in this film, the dentin compounds A3 and A2 as well as transparent and light enamel compounds were used. The powder containers are vigorously shaken before the ceramic powders are placed on the mixing plate. This causes the differently sized ceramic particles to distribute evenly. At first, the dental technician mixes the required compounds. We recommend the use of a glass plate and a glass or agate spatula. The smooth surface of the glass provides good substance retention and a consistently good mixing ratio of the ceramic particles. The ceramic is now blended with a special modeling liquid UNF. The technician examines if the compound is mixed to the proper consistency. Merely for better clarification within this film, the individual compounds were mixed and marked with food coloring. During the daily laboratory work, the compounds are easily distinguishable from one another. The dental technician starts with the application of dentin A3 compound to the shoulder of the prepared crown. Briefly pressing down strengthens the bond. Dentin A2, dyed red here, is labially applied next. The layering always follows the natural structure of the tooth. Well visible here is the way the anatomical shape of the tooth was followed. The space required for individual characterization is created by incisal and approximal trimming. The work is cleaned with a damp brush and the surface is prepared for the next step. In order to obtain the desired transparency in the incisal area, enamel transparent is applied. Enamel light, dyed blue here, is now applied. That creates the natural depth effect of colors for the ceramic work. Because of its higher chrominance, the palatinal area is covered with dentin A3. The approximal cingulum, as well as some areas of the incisal margin, is constructed once more with enamel light. Here the finished crown modellation on the model. The modeled crown is carefully removed now. Once the modellation is removed from the model, the cervical areas are filled up with dentin compound A3, again because of its higher chrominance. The completion of the labial and palatinal build-up is well visible here. The cross-section reveals the layering with caratecoline. Caratecoline enamel compounds bestow a natural-looking play of colors upon any work. The finished crown is now placed on the carrier platform for the first main firing. Now the crown is placed on the platform of the Orbotech ceramic furnace. Start once. The furnace is set. Now the main firing is done. Here is clearly visible how the crown continues to glow after it is driven from the furnace chamber. After the cool-down period, a correction firing may become necessary. For this procedure, a mixture of enamel light and enamel transparent is applied to the approximal areas. The dental technician cleans the area once more with a dry brush and slightly corrects the incisive edge. Now the correction bake is done. Finally, the glaze bake is prepared. The finished crown is placed on the master model for fitting. Then it is slightly lifted off the model. The approximal contact areas are stained with Occlu Twin occlusion paper. The matrix impressions, clearly visible here, are abraded with a diamond burr. Now it fits perfectly. In order to achieve a natural-looking surface, the anatomic outline is worked out with the grinding attachment first. Afterwards, a crosscut carbide burr is used for finishing and, if necessary, a silicone polisher for final smoothing. Carat staining pastes are used for an additional individualization of the surfaces. Hager and Welken offer a range of 8 staining pastes which may be mixed to obtain any desired color effect. Finally, the glaze compound GL is mixed with the modeling liquid carat UNF and evenly applied to the surfaces of the tooth. The subsequent glaze firing is an atmospheric bake. The finished crown fits perfectly. Well visible here is the dentin's natural play of colors and the delicately transparent incisal areas. Compared to the Vita shade A2, we see a perfect coloring. When using caratecoline enamel compounds, this comes as no surprise for our dental technicians. Caratecoline, the economic ceramic. We would be happy to answer any further questions you might have.